Welcome to the Aviator Show. In this episode we talk to Mark Hooton about his de Havilland Vampire aircraft and his 20-year quest to keep the aircraft flying and enthuse other pilots about vintage aircraft. Mark will be discussing some of the challenges of owning vintage aircraft and some of its unique features, along with sharing some in-flight footage around the UK. Mark starts by telling us some of the unique features of the aircraft, including the pneumatic braking system.
Braking systems were developed using pneumatics. So an airbag is inflated and it pushes shoes up against a drum to decelerate the aircraft. With the Vampire, Spitfires, Hurricanes, Mosquitoes, you squeeze what looks like a bicycle brake handle on the control column, and that applies brake pressure, air pressure to both wheels, push in the direction you want to go, and it'll keep the pressure on that wheel and release on the other side. Fill this up and you've only got so many brake applications. The pneumatic pressure is also used to seal the canopy. Look up here for a second. This gap between the canopy and the frame here is sealed by what's like a great big bicycle inner tube.
Yeah.
That inflates and keeps the air in. If the pneumatic brake systems fail, of course, then it becomes like a jet-propelled shopping trolley. Yeah, interesting. Still got airspeed, enough airflow over the rudders, and so you're landing, you might be able to get the aircraft into the grass, side of the runway, and it'll come to a stop. There is no emergency backup system for the brakes. They're very important, and like all aircraft of this vintage, they're a bit of a weak spot. The main accumulator pressure is indicated here, 1250 psi, and the emergency hydraulic accumulator is indicated here. So there is an emergency system for the hydraulics. The hydraulics are they're powered by an engine-driven pump, and that's for the raising and lowering of the undercarriage, raising and lowering of the flaps, the air brake, and when in service, it was also powered the windscreen wiper. So we don't fly in bad weather now, so we don't need the windscreen wiper, so that is disconnected. There is also, one more part of the hydraulics, there is a hydraulic jack to raise the canopy in an emergency if you need to get out. It'll raise a jack and the airflow, jack raises the canopy an inch or so, and then the airflow will take the canopy away from the aircraft. In service, of course, then you would be able to use the ejection seats and get yourself clear of the aircraft. Smooth aircraft is made of wood.
Wow.
So it's like an airfix kit, if you like. It's built over a mould and built up of birch and balsa in two halves, and then glued together. Once it's glued together, you sew it with wire and then cover it with fabric, dope it, paint it, and that's the complete aircraft. That's why it's so smooth with no rivets here. What you can see though, if you zoom in here, you'll see where the pinking shears have cut the fabric, cut the cotton. The rest of it, this is all timber. So that's timber from the nose back to the engine firewall.
That's aluminium?
This is an aluminium.
Yeah.
There are a few little bits of aluminium here. That bulkhead's aluminium.
So you can see on the inside, you can see where it's all riveted together now.
But the main pod is wood. We would also have a ground power plugged into that socket under there, and the aircraft needs ground power to get it going. The battery on board is insufficient to actually turn the engine over and fire the ignition system as well. You either get one or the other.
What's this little hatch here?
And this is where you'd hang the fuel tanks, the drop tanks.
Okay.
So you put drop tanks outboard here, they feed into the main wings. If it was in service, you can also carry rockets under here as well.
Oh wow.
We put rockets or bombs underneath the aircraft. There are 9 fuel tanks in the aircraft. It holds a total of 330 gallons.
And what's the burn rate?
Economy cruise, she's burning 1,200 litres an hour.
Wow.
And that's anywhere between 250 and 300 knots. There are 2 fillers on the top of the wing, one here and one here. And on the other side is the filler for the 100-gallon fuselage tank. all attached.
Have a quick look at these flaps there.
The flaps are as familiar with a Cessna 150 that you can select 40 degrees of flap. We normally land with 80 degrees of flap with the Vampire. And that's so that you've got the engine spooled up, you're not doing a glide approach.
Yeah.
On top of that, you've also got speed brakes that will flip up and extend above the wing and below the wing. On the back here, back of the elevator of the Vampire, you've got these weights here, anti-flutter weights. And here is where the engine normally sits, removed so that we can do some work on it, ensure that everything's okay for this coming summer flying season. We hope to be doing a few air shows, Ragley Hall, Cosford. Camera down here, we can check the fire bottle, the engine fire extinguisher bottle. So if we get a fire warning, we would normally reduce power on the close the throttle and fire the fire bottle. Slow down as well, 150 knots. If that doesn't work, look for somewhere to
put it
to land. Nice field. Field landing, you'll touch down, but it's got quite a bit of weight behind it. You know, it's 4 tons that you're trying to stop on those wheels. It's not brilliant. It uses about 1,000 yards to stop. The takeoff a little bit more. Temperature certainly affects it as well. So hot days, we have no problems getting it out of Coventry, say, but we wouldn't get a full load of fuel out of, say, Wellesbourne. The port side's much the same as the starboard side. You can see here the fuel inlet cap. You can see the 4 holes at the top. Well, interestingly, the tool required to open that, they're different sizes between the fuselage tanks and the main tank. Special tool for the hydraulics and the fuel tanks. As you'd imagine, each individual aircraft manufacturer back in the 40s, 50s, they designed their own tools, their own equipment. And so if you want to operate one of these aircraft, you need one of those tools. If you land somewhere and you don't have that tool, well, quite a big problem. Pitot tube, so it's a pitot static tube. Noticed it's right at the back of the aircraft, so any air flowing over the booms or the wing is quite disturbed, especially at low speeds. So the airspeed indicator sort of flickers around a little bit as you get towards the stall in this aircraft feature, but you can feel that the aircraft does buffet. It does give you lots of indication of an approaching stall.
And what's the fully stalled behaviour? Is it fairly tame? Or?
If it's just stalled, it's quite tame. If it's left to spin and enter a developed spin, then recovery can be somewhat a little bit more interesting than your average Cessna. Recommended not to spin them.
Shall we have a look at the engine? That'd
You
be
can have a look here. This is a very old engine. So this is the front of the engine. You can see they're quite wide. Looking just behind me, you can also see the red air intakes of the aircraft behind. So there's an air intake either side of the aircraft. air intake into the engine either side.
Ah, okay.
So this is the right hand side.
Yeah.
Air flows into here. There's a big impeller in here, and it throws the air out towards the outer part of the engine. It compresses it as it's thrown out here. This compressed air then travels backwards into this combustion chamber. There are 16 of these combustion chambers. To get the engine running, of course, we need the fuel burning. So we have 2 igniters, one either side.
Yeah.
Once the flame is burning in one of them, it will spread through these interconnect pipes from one flame tube to the other.
Yeah.
Obviously, when you start turning the engine over, you're only using, as the flame starts, it'll often only start in one flame tube. So the excess fuel is not being burnt in these combustion chambers. So fuel runs out the back where it may ignite further downstream through the exhaust pipe or even outside. So you'll often see the aircraft starting with a flame extending some way. So, especially at night, it can be quite impressive. So it's quite normal because it takes time. It's like a piston engine, if you can consider these as pistons, cylinders. It takes time for each cylinder to fire up, and as each cylinder fires up, it becomes more efficient.
So this bit here is effectively where the exhaust would be mounted.
So so this is the combustion chambers. The hot and fast exhaust comes out of here and drives a turbine that's just mounted behind this shroud here. Obviously there's a cover at the moment, but that's it. The exhaust drives the turbine. The turbine is on a shaft that drives this compressor, this impeller at the front. And that's all there is to it. It's relatively straightforward. The fuel comes round here from the fuel pump to a nozzle that's inside here. Generator sits here. It's a generator, old style generator, not an alternator, so it doesn't give a great deal of power while it's at idle. It works at half throttle and beyond quite adequately. Down here we've got the sump for the oil. The oil dipstick, and
that usually you check underneath the aircraft on the right hand side, isn't it?
Yes, so you check the dipstick from underneath the aircraft here and fill it up from on top. So you've got to get back on top of the aircraft to fill it with oil. Starter motor is on the other side, and this is the tacho drive. It's only got two spark plugs. One here, one on the other side. So when we start up, you'll hear it click, click, click. And that's the spark plug.
Sounds like when you're igniting your cooker.
Yes, exactly. High energy ignition unit that's mounted down here. Sends a spark up to here, and click, click, click. You'll hear it until it starts up. The start process is automatic once you engage the clockwork system. You hold the start button in and it takes a couple of seconds for it to wind the system up. Once you release your finger from the button, you've got 40 seconds before the starter motor cuts out automatically. Most of the British jets work that way. They've got a clockwork system for the starting.
Should we have a look in the cockpit?
Yes. They don't have cartridges in, but they'll make a big mess of things if you do. Well, I have to put it all back together. When we get into the aircraft, put our hands on the window frame, and to steady ourselves, climb up the ladder, step down onto the brown seat here. What you see then behind you here is this green parachute. The strap comes over the right leg, one over the left leg, and straps on there, and one across the chest. That's the parachute. Then the main harness is this one here. It comes up here. So the parachute and the harness are slightly different, of course, to your average light aircraft, and it does take a few trips before we become familiar with the parachute, the seat, and the harnesses.
Yeah, and this ring pull here is the old ejector seat.
If the cartridges, when the cartridges are fitted, the means of firing them and ejecting yourself from the aircraft is to reach up and pull this, and that pulls the blind down over your face. Yeah, and a second later you're being projected. So there is a minimum speed and height for these seats. It's very old type of ejection seats, and you need to be 200 feet and 120 knots for them to work. Not a lot of room, is there? No. That's the first thing you notice. Interesting accidents. It takes quite some time to actually strap in. I'm not going to go through the whole strapping in process. It would take far too long. So once you are in, you attach yourself to the parachute. There's a strap over each leg and then one around your waist. Then got the parachute on. If you had to get out of the aircraft, it was just a matter of pulling this handle, the canopy disappears, and you can slow down the aircraft and jump out. Rather unusual, there is a negative G strap. Right, so it's a 5-point harness. Yeah. This is the high energy ignition unit switch. If I push that, you'll hear the click, 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 and the throttle. You can see it's repeated here, left and right. This button on the end of the throttle is the push to torque. This twist is for the gun sight. Moving along, we've got the brake pressure. These three needles, the top needle shows the total system pressure, and that's the pneumatic pressure that we would have topped up to 450 psi before we jumped in. When we apply the brake handle here, this handle that looks like the bicycle brake.
So is there no toe brake as such?
There is no toe brake, no.
Oh, okay.
So you squeeze that, and if you've got your feet symmetrically on the rudder pedals, you'll get equal pressure to both main wheels. We've got the inverter CBs. These are for the guns, armament system, lighting for the gyro gun sight. Clocks, EGT gauge, very important with the gas turbine, and the tacho.
So what's the max RPM on it?
So 10,700, try to limit it really to 10,000 RPM. Max power for takeoff maybe very briefly, and as soon as it's safe we throttle it back. Set your pressure settings there. Airspeed indicator, like this tacho, it goes around once to 350 and then you read on the inside. A modern transponder and VHF radio, compass, cabin altitude. It can be pressurized. Normally it would only be pressurized above 20,000 feet. The inverters power just these two flight instruments, and these two, of course, operate off the pitot-static system. This is DC, turn and balance. Start master, to go through the start sequence, you'd turn the start master on. You turn on the boost pump, the low pressure light would go out over here, and you'd hold that in, count to 3, 1, 2, 3. You'd hear everything engaging, clunk, 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 and the engine would then slowly start to turn. It starts initially turning slowly so that there's no crash engagement of the gears from the starter motor, then slowly winds up. Eventually the engine should light up. It needs 1500 RPM before it'll accelerate. If it's below that, it'll just hang there.
Very difficult to illustrate how small it is in here for the viewers. I think when we get out, I might see if I can get a better shot of it, but it's literally
There's not a lot of room.
There's not a lot of room at all, no.
And we're not strapped in, and we don't have leg restraints on, we don't have the May West, we don't have all the equipment on, helmets, etc, etc.
Yeah, exactly. Is it okay to move the controls?
Yes, of course, yeah.
They're fairly light, aren't they, considering? But I imagine when you're moving, it's quite heavy to get off the ground.
No, it's quite a light aircraft to fly, quite easy to fly. The biggest difficulty is keep monitoring your air pressure on the ground and making sure you don't lose the air pressure, because you'll lose your brakes. So that's very important. And if you do come to a stop, you've got to be aware that if it's over bitumen and you stop for too long, it will start melting the bitumen. And if you then apply power to start to move again, if once been held, you find you'll dig holes in the runway.
So yeah, I've noticed that there are specific places where you actually start the aircraft, and it's for that reason then, so you're not melting the tarmac.
Yes, we always start the aircraft over concrete where we can, or with the exhaust over grass or something like that, so the grass will grow back, but not over soft bitumen, otherwise that will melt, and when you put the power on, the molten bitumen is blown away, which no one wants. Yeah, it's fairly straightforward on the ground. So apart from the braking system, and once airborne, the aeroplane's thoroughly enjoyable. You select the gear up. Don't confuse the gear and the flaps. The left hand has to do quite a bit. You don't really want to be looking down. You select the gear up, flap up, and the aircraft is is very nice to fly at all speeds. Between 200 and 350, 400 knots. It's quite sensitive in pitch at high speeds, above 300 knots. You can easily overstress them if you're keeping that in your scan, and if you're not aware of that is an issue. It's got a reasonable roll rate, very well balanced primary flight controls. The only problem it does have a high fuel consumption, so you must monitor this. Fuel gauge, if you don't have that, you're checking that against the clock, what's your rate of burn, and you don't really want to embarrass yourself by not having sufficient fuel. That's right. So
right, everyone wants to know about rockets and guns and stuff like that.
Yes. Okay. So the guns are controlled by these selectors here. You can either select rocket projectiles or guns. As you know, it's got 420mm cannons underneath. Again, more of the gun selector. Safety catch on the top there. Raise that. As you can see, the trigger that flips down here. Okay, that's for the rockets or guns, and this is purely for the camera. The gun camera mounted in the nose. Over here is the rest of the armament panel, whether you want to how the rockets are to be fused, and other selections on the rockets. The first Vampire flew in September 1943. The engines were running, the Goblin engine were running throughout 1942 though. I just didn't have the aircraft ready. So 2 Vampire engines were used to power the first Meteor. That was back in March 43. This aircraft wasn't built until many years after the war, 1952. It was built at Christchurch down in Bournemouth. It was a development of the 2-seat night fighter, so it was a single-seat intercept fighter, replacement for a Spitfire initially, and they were frontline fighters between 46 and 66. They then developed it into a night fighter, and from the night fighter they thought, well, we better have a trainer version. And this is what we've got, the 2-seat Vampire trainer on this one. So built in 52, remained in service at various RF training stations for about 10 years before ending up being used as a target for controllers at Exeter and Shawbury, just being radar vectored around the sky, giving many cadets some fun and a bit of a joyride at the same time. It was then disposed of by the RAF, and it went to a museum, Solway Aviation Museum at Carlisle. It was in such good condition they decided to get the aircraft flying. And in it was 82, they got the aircraft airworthy and flying and on the UK Civil Register.
So how did you come about to be?
There was a group of us intending to buy and operate the aircraft, and We bought it about 20 years ago. One by one, the other members
Dropped
got
out.
married, children and other duties took
Require
priority,
money.
and they moved on, moved away. We've had many people come and learn how to fly the aircraft. It's anyone with a PPL can fly this aircraft. As you can see, it's relatively straightforward.
Just let this helicopter go quick.
On a helicopter. And he's off. So there's no reason why anyone can't learn to fly this aircraft.
Interesting enough, let's not go too much into that because we're going to do a separate episode out
Okay.
all about learning to fly military jets on a PPL.
This was designed as a trainer, military trainer, and that was its purpose.
So when did it go out of service?
Well, as an interceptor, they went out of service in 1966.
Okay.
So they were frontline fighters for 20 years, which is quite amazing considering the
absolutely.
rate of development of aircraft back then.
Yeah.
As you can see, this aircraft's got a straight wing.
Yeah.
And by the time it was in service, the swept wing aircraft were already being being produced and entering service.
So your sole purpose for buying it was to preserve the aircraft and keep it in use and train people on it?
Initially, yes, just to preserve and fly it. It's become more and more difficult, but a challenge to keep it flying, and that's our objective, to keep this aircraft flying for as long as possible.
And what are the kind of challenges you face when trying to keep an aircraft like this flying?
There are many. There's where to hangar it. It needs a dry hangar. As we said, it's made of wood. It's covered in fabric. It needs a good dry home. It needs a relatively long runway. A grass runway in the UK in winter just wouldn't work at all. On top of that, parts wear out, tyres, inner tubes, brakes, so they're difficult to obtain. Yeah. And often things like tyres will need a minimum order. Yeah. And that will amount to thousands and thousands of pounds for a minimum order of just tyres, for example. Yeah. The spare parts, expertise when it comes to maintaining instruments, various items in the aircraft that are no longer in service, that can become quite a challenge.
You were saying that you were making your own tools to do work on the aircraft because you can't no longer get them.
The tools it's very difficult to find the tools now that we used to service the aircraft. So in fact, yes, we have to manufacture our own tools to carry out the work. Wow. And to find the drawings for those tools is a challenge as well.
Absolutely, yeah. So the other thing, Mark, obviously I'm sure that the viewers would be quite interested to find out more about what you're doing with the aircraft and where they can see it. Do you have a website that they can look at where your events are and those kind of things?
Yes, we have a vampirepreservation.org website. They can
I'll put a link to that in the show notes as well, so people can actually link to it. And then, but yeah, if this is something that you guys fancy doing, come on down, have a look at the Vampire, even book yourself a flight. That's something they can do, Mark, is it?
Absolutely, yes. Come down and any of your members, once they learn to fly, feel free, come over, and perhaps they'd like to experience a jet flight. It can be the very first jet flight. We can train someone up to fly the aircraft solo. That's full Vampire type rating exemption.
Yeah. So we're going to do a whole other episode on that, which I'm really looking forward to, because there's another aircraft we're going to look at, which you also own, is the Jet Provost Mark III. So yeah, a whole new episode coming, guys, about, and that's on the Student Pilot podcast, not this particular series, all about how you can fly a vintage jet on a PPL. Well, thank you ever so much for your time, Mark. It's been a real pleasure doing this. If you like this video, please like, subscribe and ding the bell to watch more videos like this one.